All right, so today we are reviewing what we talked about yesterday and doing a little bit more. So just a few review things so that I figured this will be our anchor chart. I kind of started it without you, but I'm going over it with you. So polygons are two-dimensional. They're flat shapes, okay? They're closed. So on the video they said, like, pretend you put an ant inside of one. So like, okay, here's a little ant. And can it get out? It can't get out. Then it is then that's a closed figure, okay? And then the other thing is that it has, so it's closed. And the other thing is that it has sides, vertices, and edges. So sides are these flat sides, and yesterday we called them line segments. Okay, it's got vertices, which are these kind of like where two sides meet, okay, so kind of the edge there, and then angles, okay, and it's so polygons have interior angles. If you look at my examples down here, you can see that they all are two-dimensional or flat shapes, they all are closed, and they all have sides, vertices, so picture like if you put your finger on there, it would get poked, okay, it's kind of a where to meet. And then they all have interior angles. I actually colored the interior angles with a marker already because we're going to be talking more about that today. Okay, so one last thing is a review. Polygons, one thing I thought was helpful is polygons means many angles in Greek, okay? So it makes sense that all of these polygons have have many angles. Okay, another thing before we move on to our new stuff, so just a review, that they can be regular, okay, or irregular. Now we see regular the most because they're regular or usual or kind of like the basic normal ones. And those are polygons that have equal sides or equal angles. But there are also irregular ones, okay? So, for example, this has 1, 2, 3, 4, 5 sides and 5 angles. It is a pentagon. This also has 1, 2, 3, 4, 5 sides and 5 angles. It is also a pentagon. This is a regular pentagon and this is an irregular pentagon. Okay, so they're both pentagons, but you can see that depending on if these sides and angles are equal, that whether it's classified as a regular polygon or an irregular polygon. Okay, so next up, something I'm just going to tell you, and I want you to take my word for it for now, but once we use protractors, you can measure it yourself and check me. But the interior angles, and when I say interior, okay, I want you to think about the inside angles. So that's kind of, you know what, I'm going to write that up here. That's an important word, is interior. It's kind of a fancy word, and it means inside. There's a job that's an interior decorator or designer, and they work on the inside of mostly homes, maybe buildings, to decorate them or design them or you know, work on the layout, even the fabrics and all that kind of stuff. So an interior designer works on the inside of a building or a home. An interior angle is an inside angle in math, okay? That's important. All right, so thinking about those interior angles, now we can look at these down here. You can see that a triangle has 3 sides, okay? We talked about triangles, 3 sides. Tri means 3. So just like a tricycle is 3 wheels, okay? So what I want you to take my word for is that if you add up this angle, which by the way is it bigger or smaller than 90 degrees? Oh, that's smaller than 90 degrees, this angle right here. That one is acute, this one is acute, and this one is acute. If you add up this acute angle plus this acute angle, so remember angle, I'm saying the opening there. If you add up this opening, and this opening, you would get 180 degrees. And that's what I want you to take my word for. Eventually, we'll measure it. If you add them all up, This one isn't 180 degrees. This one isn't 180 degrees. This one isn't 180 degrees. They're actually each 60 degrees if it's perfect, if it's regular. But either way, triangles, even if they're irregular, their insides, their 3 interior angles add up to be 180 degrees. If you know that rule, and I'm going to say that for now because you're not measuring it yourself, that's just a rule that I'm asking you to know and consider. If you know that rule, I want to show you something. What if I'm trying to find out, well, how much do these inside angles in a 4-sided shape add up to be? And by the way, 4-sided is called quadrilateral. Quad means 4. Could be squares, rectangles, rhombus, trapezoid. This one kind of looks like a rectangle, I would say. But if I want to add them all up, this one plus this one plus this one plus this one, and by this one I mean the inside angles, if I want to add these all up, I can use the triangle to help me. Watch. I split it. How much does the inside of a triangle add up to be? Well, wait a minute. That means these 3, 1, 2, 3, must add up to be 180 degrees. And these 3, 1, 2, 3, add up to be 180 degrees. So the inside of a triangle, the inside measurement, must be 180 plus 180. And you get 360 degrees, okay? So I wanted to show you that you could do that for all of these shapes. It's kind of cool because now you know triangles add up. Their inside angles add up to be 180. Well, here's a triangle, so that must be 180. Here's a triangle, so that must add up to be 180 in the inside angles, Oh, there's another one, 180. So if I do 180 times 3, because there's 3 of them, 1, 2, 3. 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3. 4, 5. I can find out that a pentagon's inside angles add up to be 540 degrees. So it's kind of cool because you can do that. So again, the triangle, the inside adds up to be 180. These 4-sided shapes, their insides add up to be 360. A 5-sided shape, a pentagon, its insides add up to be 540. And you can keep going, okay? Because you can keep finding triangles in all of these shapes. Oops, sorry, I should have put that one there. Oops. Okay, so that is, sorry, I did that a little messy, but that is 180 in the inside there. 180 must be in the inside there. This one should be 180 in the inside there and 180 in the inside of there. So this is just going to be 180 times 4 in the inside. 4 times 0 is 0. 4 times 8, 8, 16, 24, 32. So 32. 4 times 1 is 4, 5, 6, 7. So a hexagon inside angles should equal, or do equal, 720. And I didn't even have to measure them. I did that by figuring out what a triangle was. And then I found the triangles in them. Okay, I can do it with all of these shapes. Okay, so something that we're going to be working with is finding the interior or inside angles of polygons. Okay, I know this looks a little messy. Oh, and by the way, we won't do this right now, but heptagon is 7 sides, octagon is 8 sides. It keeps going, but those are kind of like the basic ones that you will be hearing about. This anchor chart looks a little messy, but they always do. But as long as you are listening, I think that you understand it. Okay, so I'm going to take a picture of it as well, and that way it can be a resource for you. I hope this helps.